The night sky is currently undergoing significant changes that will alter its appearance over the coming years, if not decades. Experts and astronomers worldwide, including figures like Neil deGrasse Tyson, have sounded the alarm about an extraordinary shift happening with Polaris, the North Star. Polaris' central role in the night sky has long defined its uniqueness, acting as a steady reference point for navigators, astronomers, and even pilots. However, this stability may soon be disrupted, causing a fundamental change in both the night sky and our understanding of cosmic measurements. To grasp the severity of this change and its potential effects, let's explore the history and significance of Polaris, which is now in its final stages. Polaris has been regarded as the guiding star for centuries, helping sailors and explorers navigate the seas and land masses. Its near-perfect alignment with Earth's North Pole has given the illusion that it remains stationary in the northern sky, making it indispensable for celestial navigation. However, recent findings, notably from the Royal Astronomical Society in September 2023, have cast doubt on the star's future. Polaris is nearing an explosive event that could cause it to disappear from the night sky forever. Before delving into the potential consequences of this revelation, let's take a closer look at Polaris itself. Also known as the North Star, Polaris occupies a unique position in the sky due to its proximity to the celestial North Pole, sitting nearly directly above Earth's North Pole. This is why it has been a constant reference for navigating the Northern Hemisphere. Located in the constellation Ursa Minor, Polaris is a moderate brightness star that stands out as a yellow-white supergiant. Despite its appearance as a single star, Polaris is part of a complex triple star system. The primary stars in this system are Polaris AA and Polaris E, which appear as a single point of light to the naked eye. Additionally, there is a third companion, Polaris B, which orbits the two primary stars. The gravitational interactions between these stars influence their orbits, brightness, and other characteristics. Polaris is located about 430 light-years from Earth, meaning that the light we see from it today was emitted over 430 years ago. This distance implies that if Polaris were to explode today, we wouldn't know about it until 430 years later, as the light from the event would take that long to reach us. For centuries, Polaris has been essential in guiding human civilizations. Its steady position near the celestial North Pole made it a reliable tool for navigation. Ancient sailors and explorers relied on Polaris to determine direction, particularly in the northern hemisphere. The star's symbolism as a constant and unwavering beacon of guidance has given it cultural significance in various societies. Recently, however, Polaris has shown unusual behavior. Its once constant pulsations have become erratic, with periods of dimming and brightening that deviate from its typical rhythm. This behavior has raised concerns among astronomers, suggesting that Polaris may be approaching the end of its life. This change is consistent with the behavior of stars nearing the end of their life cycles. Notably, the lengthening of Polaris pulsation cycles, increasing by about 4.5 seconds, might seem minor, but it is highly significant. Some astronomers speculate that the gravitational interactions between the stars in the Polaris system could be influencing these changes. Others, however, believe that Polaris is nearing an explosion, based on its increasingly erratic behavior. This suspicion is fueled by parallels with Betelgeuse, a prominent star in the constellation Orion, which has also exhibited sudden changes in brightness. Some experts have warned of the inevitable demise of Polaris, emphasizing the sudden variations in its brightness and behavior, traits often seen in stars at the end of their lifespans. NASA has taken particular interest in the anomalies observed in Betelgeuse, though it has not issued similar statements regarding Polaris. Stars undergo significant transformations throughout their life cycles. When they are young, stars like Polaris are cooler and less luminous. Over time, they enter the main sequence phase, where nuclear fusion sustains their stability for billions of years. Eventually, as their hydrogen fuel is depleted, they enter the red giant phase, during which they rapidly increase in temperature and luminosity. This stage culminates in a catastrophic explosion, known as a supernova. If Polaris were to go supernova, it would be a truly spectacular event visible from Earth. The star would become incredibly bright, outshining even the moon, and would remain visible for days, weeks, or even months. Its appearance would undergo dramatic changes, with the star likely transforming into a brilliant temporary point of light, possibly showing different colors before fading away. Such an event would drastically alter the appearance of the Ursa Major and Ursa Minor constellations, which include Polaris. Fortunately, we would be safe from any direct harm. Given Polaris' size and distance from Earth, a supernova would not pose a danger to us. While the visual spectacle would be breathtaking, the explosion itself would have little impact on Earth. Despite the awe-inspiring display, a supernova from Polaris would not be as catastrophic as Betelgeuse's potential explosion. However, it would remain visible to the naked eye for an extended period, possibly outshining other nearby bright stars and leaving a lasting imprint on the night sky. Stars like Polaris hold the potential for a cosmic explosion, one of the most dramatic events in the universe. These explosions release immense amounts of energy and matter into space when a massive star exhausts its nuclear fuel and can no longer sustain the fusion reactions that support it. As a result, the star undergoes a catastrophic collapse, triggering a violent explosion. Such a blast, visible across vast distances, can briefly outshine entire galaxies and leave behind remnants like neutron stars or black holes. If Polaris were to undergo a supernova explosion, astronomers predict it would become one of the brightest objects in the night sky, potentially rivaling the moon's luminosity. This sudden flare-up would be accompanied by dramatic changes in its visual appearance, transforming Polaris into a spectacular point of light, visible to the naked eye for a short time. This event would not only captivate astronomers but also provide valuable data on the final stages of stellar evolution. The study of Polaris's potential supernova is more than just theoretical. It holds practical implications for both science and humanity. Despite its cosmic significance, a supernova from Polaris would pose no immediate danger to Earth due to its vast distance of approximately 323 light-years. Any effects from the explosion would be limited to the light and radiation it emits during the event. From a scientific perspective, the supernova of Polaris would offer a unique opportunity to study the physics of stellar explosions and their impact on surrounding space. Astronomers would closely observe the explosion's progression, from the initial burst of light to the formation of nebulae and remnants that continue to expand across the cosmos. These observations could provide insights into the origins of elements essential for life, such as carbon, oxygen, and nitrogen, which are created in the intense heat and pressure of supernovae. Furthermore, the supernova of Polaris would have broader implications for our understanding of the universe's structure and evolution. By studying how stars like Polaris end their lives, astronomers can refine models of stellar evolution and improve predictions about how galaxies, including our own Milky Way, will evolve over billions of years. The remnants left by supernovae play a crucial role in the formation of new stars and planetary systems, shaping the cosmic landscape we observe today. Polaris holds significant cultural and historical value as well. For centuries, it has guided navigators across oceans and deserts, serving as a reliable reference point for navigation and exploration. Its constancy in the night sky has inspired myths, legends, and scientific inquiry, symbolizing the enduring quest for knowledge and understanding of the universe. In ancient times, Polaris had profound navigational and spiritual significance in various cultures. In Norse mythology, it was associated with the god Odin, who was believed to guide souls to the afterlife. In Chinese astronomy, Polaris was revered as the central star, around which all other stars revolved, representing order and stability. Throughout history, Polaris has symbolized direction, leadership, and the timeless principles governing the universe. The potential disappearance of Polaris as a visible star would mark the end of an era in both astronomy and cultural heritage. Its absence would not only disrupt navigational practices but also alter our perception of the universe and our place within it. The constellations Ursa Major and Ursa Minor, with which Polaris is closely associated, would lose their guiding star, reshaping the stories and interpretations that have endured for millennia. While the future of Polaris remains uncertain, ongoing observations and research efforts aim to unravel the mysteries surrounding its behavior and predict its eventual fate. Advanced telescopes and observational techniques enable astronomers to monitor Polaris's brightness, spectral characteristics, and pulsation patterns with unprecedented detail. These observations provide crucial insights for theoretical models and simulations that replicate the conditions within Polaris and forecast its future evolution. The study of variable stars like Polaris is part of a broader effort to understand the diversity of stellar phenomena and their impact on the universe. Variable stars exhibit changes in brightness over time, offering valuable clues about the physical processes occurring within stars and their evolutionary paths. By studying these variations, astronomers can classify variable stars into different categories based on their behavior and identify the underlying mechanisms driving their variability. Polaris's status as a Cepheid variable star places it in a class of stars used to measure distances in the universe. The relationship between a Cepheid star's pulsation period and its intrinsic brightness allows astronomers to calculate its distance from Earth with great accuracy. This method, known as the cosmic distance ladder, forms the basis for measuring distances to galaxies, star clusters, and other celestial objects across vast cosmic scales. The precision of distance measurements obtained from Cepheid variables like Polaris has far-reaching implications for our understanding of the universe's size, age, and rate of expansion. By refining these measurements and calibrating the cosmic distance ladder with precise observations of nearby variable stars, astronomers can improve their estimates of the Hubble constant, a key parameter that describes the rate at which the universe is expanding. These measurements contribute to cosmological models that trace the evolution of the universe from its early origins to its current state. In summary, Polaris occupies a unique position in both the night sky and human history, representing the ongoing quest for knowledge and understanding of the universe. As a Cepheid variable star approaching the end of its life cycle, Polaris offers astronomers a window into the processes that shape the birth, life, and death of stars. The potential supernova of Polaris would not only be a scientific milestone but also a cultural and historical turning point, reminding us of our place in the vast and ever-changing cosmos. The potential cosmic explosion of Polaris would mark a monumental event in galactic history, providing researchers with a rare and valuable opportunity to study a star's catastrophic demise up close. Despite its current stability, the irregular pulsation patterns of Polaris, along with the gravitational interactions within its triple star system, suggest an impending transformation. Astronomers continue to monitor its behavior closely, searching for clues that could shed light on when and how this celestial change will unfold. The extraordinary position of Polaris as the North Star only amplifies its significance, potentially altering millennia-old navigation practices and cultural symbolism across human civilizations. Known scientifically as Alpha Ursae Minoris, Polaris has been a steadfast fixture in the night sky for centuries. Positioned directly above the Earth's North Pole, it serves as a crucial reference point for navigators and astronomers alike. Its proximity to the celestial pole gives it the appearance of being fixed in the sky, making it a reliable marker in the northern hemisphere as the Earth rotates. This consistency has earned Polaris a prominent place in human history and culture, where it has been revered as a guiding light in the vastness of the universe. The scientific interest in Polaris extends beyond its navigational utility. As a star nearing the end of its life cycle, Polaris presents a unique opportunity to study stellar evolution and the processes that govern the birth and death of stars. It belongs to a class of stars known as Cepheid variables, which are characterized by periodic fluctuations in brightness. These pulsations are linked to changes in the star's size and temperature, providing valuable insights into the internal dynamics of stars. Ongoing observations and studies have revealed unexpected behavior in Polaris' pulsation cycle. Rather than following its usual pattern of gradual dimming and brightening, Polaris has shown irregular fluctuations in brightness. This inconsistency suggests significant changes within the star, potentially indicating instability in its core. While such variations are common in variable stars, the implications for Polaris are noteworthy, especially given its role as the North Star. A pivotal moment in the study of Polaris came with a 2023 report by the Royal Astronomical Society, which raised significant questions about the star's future. The report suggested that Polaris might be approaching the end of its life cycle and could potentially undergo a supernova explosion in the near future. This revelation sparked renewed interest and intense scrutiny from astronomers around the world, prompting them to intensify their observations and research. The potential supernova of Polaris involves delving into the complex dynamics of its stellar system. Polaris is not a single star, but rather part of a triple star system consisting of Polaris AA, Polaris AB, and Polaris B. Polaris AA and AB form a close binary pair, while Polaris B orbits this pair at a greater distance. The gravitational interactions between these stars affect their orbits and behavior, contributing to the overall stability or instability of the system. The presence of Polaris B introduces additional gravitational effects that could disrupt the system, leading to the anomalous behavior seen in Polaris pulsation patterns, which may indicate changes in the star's internal structure. Theoretical models of stellar evolution suggest that stars like Polaris undergo dramatic changes as they near the end of their lives. Initially, Polaris would have been a relatively cool star, slowly progressing through the main sequence phase, where nuclear fusion in its core sustained its brightness and stability for millions of years. However, as Polaris exhausts its hydrogen fuel, it enters the later stages of stellar evolution, marked by dramatic increases in both temperature and luminosity. The red giant phase represents a critical stage in a star's life, during which it expands to several times its original size and becomes thousands of times brighter than before. For Polaris, this phase would signal a significant surge in its energy output, potentially making it noticeably brighter and more prominent in the night sky. This change in appearance could affect its role as a navigational reference point, altering its symbolic significance across human cultures. Beyond the red giant stage lies the ultimate fate of the star, which could include a spectacular supernova event, forever transforming the star and its surrounding environment.